Hello, it's Professor Gibson. Here's a short video on how to find an exponential equation that matches a given graph. Okay, so in general, here's what we're trying to do. They're giving us a graph, and we want to find an equation that looks like something like this that'll match it. Remember the C, this here is the initial value. In other words, this is the value when b equals x. We've also got this was the vertical shift. The other thing we have to determine is whether or not there's a minus sign on the x. All right. So in order to do that, let me first, by way of reminder, draw the standard graph. Looks something like this. All right. So if your base is a number bigger than 1, here's the standard graph. Looks something like this. All right. The horizontal asymptote is down here at y equals 0, and it points to the left. Those are both key. We're going to use that. We're going to use that heavily. Another element of this, actually, there's other things we could put in here. You could add a horizontal shift and things like that. It turns out that there's more than one function that would match each of these graphs, which allows me, will allow us to only look at this format. Okay, we don't have to worry about others, and I'll show you one of those about what I mean once we find this one. All right, so here's the first one right here. Let's start with this one. Okay, so the horizontal asymptote is still pointing to the left, so that tells us the x is still positive, right? If it was negative, that would be a negative inside the function, then x has got a negative on it. And if you remember, that would be that would flip things around the y-axis, right? So if you ever, when we have one, if you have one where the horizontal asymptote points to the right, then we'll make it a negative negative x. So in this case, it's still pointing to the left like the original, so we're good with that. Let's find the k, right? The standard function has the horizontal asymptote at 0. This has it up here at 7. So this tells us that our k is 7. Right? Okay. Let's now, every one of these, these functions that they're given, of these graphs, has at least 2 points where it crosses exactly on the grid of the graph, which means that we have 2 points, we have 2 exact points we can just write off. So on this one, it's 0, and not only that, actually, on every single one of them is where it crosses the y-axis, which makes it easier for us to find the c. So this one right here is x is 0, y is 5, and this one's x is 1, y is 1. All right. Now, the vertical shift actually gets in the way of finding the c, okay? So what I'm going to do is we've already found the vertical shift, we're just going to drop it off. So let's write a new function. I'm just going to call it g, all right? Has the same c, the same b. We're still looking for the C and B. We're going to drop off the 7. In other words, what I did is I just subtracted off the vertical shift. Okay, so if I did that, what happens to these 2 points? Well, when I added the 7, all it did is a vertical shift, so it adds 7 to the y, right? So on my new function, I have to subtract 7 from the y. 5 minus 7 is minus 2. And then the y over here is 1. 1 minus 7 is minus 6. All right. Now, this is the part where they're being friendly, this point right here. Remember, the c is, when you don't have a k, the c is the initial, right? When x is 0, this is the initial value here. The c is the initial value. So since we have a 0 minus 2, and now there's no k, we can now read this right off. C is minus 2. All right? So our g here, okay? So we're making good progress. We've got the c, we know the x is positive, and we've got our vertical shift, which we'll go back and plug in at the end. Now we use our other point. Let's use this one. Let's just plug it in. When x is 1, the function is when x is 1, the function is minus 6. So minus 6 equals minus 2, right? B, plug in 1 for the x. All right. Now we've got to solve for b. Divide both sides by minus 2. 3 equals b, right? B to the first is just b. So in this case, we've got everything now. When we're done, we just write it all out in one place. F of x equals, we know the c is minus 2, we know the b is 3, we know the x is positive, and up here we got the vertical shift was 7. All right. Now, if this in here bothers you, the reason I took off the 7 and went forward, right, is because it gets in the way of calculating the c. You could still do it, it's just easier this way. All right. So crack, when you drop off the vertical shift, this is probably the key thing right here. Notice as I went from here to here, when I cut off the vertical shift, I just subtracted the vertical shift then from both y values of both points and went forward. All right, so here's this one. All right, so now I'm going to do another one. I recommend you, if you feel like you got this, you think you have what I just did, let's look at the next one here. Stop the tape, right, or stop playing and go ahead and try to work this out. If you don't see it well enough yet to do that, then just follow along with me. I'm going to do 2 more of them. All right. So again, my starting thing is f of x equals c b to the x plus k. C is the initial value, at least it is when you don't have a k, or when k is 0, how you want to say that. B, there may be an x, we need to find the b. There may or may not be a minus sign on the x, and we need to find the k, which is the vertical shift. All right, first thing now, notice this time, the horizontal asymptote is pointing to the right. Remember, on the standard one, it points to the left. So this thing has been flipped across the y-axis, so that means we have a minus x. All right. The standard horizontal is at 0, y equals 0. This one's up here at y equals 5. So this time our k is plus 5. All right, let's get our 2 points. As I said, every time we have one that's nicely on the grid line, the crosshairs of the grid there at 0, 3. I think this one has 2. You could use this one up here. I'm going to use this one down here, minus 1, minus 1. All right, now we're going to get rid of the vertical shift. So I'm going to change to another function here with the same c, the same b. Since we've gotten rid of the vertical shift, that means we need to subtract it off the y values of our 2 points. So it was 5, 3 minus 5 is minus 2. Then our y value here is minus 1, so minus 1 minus 5 is minus 6. Again, we have a 0 here, right? Since this is a 0 and there's no shift on this one, the c, this minus 2 is the c. So we now know we've got minus 2 b to the minus x. Now it's time to plug in the other point. Negative 1, 6, so when x is minus 1, the function is 6. Minus 6 equals minus 2 b. Remember, it's to the minus x, right? So minus, then we're plugging in minus 1, minus 1. Minus 1 is plus 1, right? All right. Minus 6 divided by minus 2 is 3. And this is b to the 1, right? Which is b. b to the 1 is b. So b is 3. If you notice on this one turns out to be pretty similar to the initial one. We have everything we need now. We have our f of x. All right. We have our c here at minus 2. We know the b is 3. We know it's to the negative x. And we've got the vertical shift up here at plus 5. Done. All right. If you kind of compare the shape of this second one I just did to the first one, if you move the graph, you cut the graphs out and line them up, you can see the shapes are pretty much the same. They've been flipped across. This one's been flipped across the y-axis and shifted differently, but the basic shape's the same. That's why they're both the 3 and the 2 looks quite similar in some ways, if you kind of eyeball the shape of it. All right, one more. Again, so I'm going to recommend if you feel like you've got it, go ahead and pause the video while we and work this one out, and then come back and see if you get the same thing that I'm about to get. All right, so we'll start again. Function is, oh, you know, I told you there's more than one way to write each of these, so let me show you something here. Let's go back up to the first one. See, this is 3 to the x. If you wanted to, remember a minus in the exponent means take the reciprocal, so you could write this way. So you put a minus on it, it takes the reciprocal. Now that one's kind of odd to do that because you'd have a minus and a 1/3. You probably wouldn't do that one, right? But by the same token, instead of putting a minus on the x, we could have taken a reciprocal. So this is the same thing. Put the minus on here with a positive x. All right, these two are the same. When I did ones like these in the homework, I did them this way. I always did it with the base that was bigger than 1. Okay, and so I did that one. There's other things you can do here by changing. We're ignoring the possibility of a horizontal shift because it turns out that the horizontal shift can be adjusted for in the factor. You can't do that with most functions, but the way these exponentials work, you can. So anyway, that's how it works. My comment about how there's more than one way to write these, that's what it comes down to. All right, go back to this. Horizontal equals c b to the x. Remember, we'll check whether or not it's a minus x, and then plus k. All right, the horizontal down here is pointing to the right, so that's going to give us a minus x, because the standard horizontal, if you remember, points to the left at the y-axis. All right. The standard horizontal is at 0. This one's down here at -4, so the k is -4. All right, let's find our 2 points. Here's one right on the y-axis, and up here, here's another one. There's the other place where it crosses the grid. So our 2 points are the points 0, -2, and -2, 4. All right, now I'm going to pick another function that's the same. I'm going to throw away that vertical shift just because it makes it much easier to find the c. All right, so when I get rid of the vertical shift, I have to change my points to match. And so I'm going to subtract off -4, right? Subtract off -4 means I'm going to add 4. So, right, the y goes up by 4. So -2 plus 4 is 2. And then the y over here was 4. If I add 4 to it, it's 8. All right, again, here's where x is 0. There's no vertical shift, so we can read the c right off. It's 2. So my g of x is now it's 2 b to the -x. All right, let's slide this down a little more, get a little more space to write. Okay, now again, we're almost done. Got to plug in the point we haven't used. When x is -2, the function is 8. So 8 equals 2 b is to the -x. Now I plug a -2 in, so you get another minus and a 2. All right, minus makes, so that's a +2. All right, now let's solve for b. 8 divided by 2 is 4. b to the +2 is b squared. All right, take the square to both sides. b is 2. Now I've got everything I need. So my function, my c was 2, right? b is also 2 this time. It's a -x. And the vertical shift was -4. All right, so there's this one. I hope you found that helpful. If you have any more questions, just send me an email and let me know. Thanks very much.